Welcome to SWAM's online lecture series on the topic Database Management System. I am Professor Mahullah Bukhari, working in the Department of Computer Science, Aligarh Muslim University. I am pleased to have you join me today as we explore the fascinating realm of databases, database management system. In the next few minutes, we will journey through the foundational concepts and database management architectures that form the backbone of modern information system, which is the database management system. In the previous session, we have discussed different type of database users, naive users, application programmers, sophisticated users, specialized users, and characteristics of the database. Before proceeding with today's agenda, I would like to discuss some questions that I had given you in the last class. The first question was, what are the different types of database users? The answer is, database user encompasses a spectrum including naive users with a minimal technical expertise, application programmers crafting software solutions, sophisticated user delving into advanced data analysis, and a specialized user tailoring database interaction to domain specific needs. Each type plays a unique role in maximizing the potential of database management system. The next question was, how does the database management system ensure a user-friendly experience for naive user? The answer is, database system ensure a user-friendly experience for naive user through intuitive interface, minimizing technical complexities, graphical tools, clear navigation, and simplified data entry processes cater to their limited technical knowledge. Additionally, user training and accessible support mechanisms are implemented to aid in understanding and utilizing the system effectively. The design priorities simplicity without compromising essential functionalities, ensuring a seamless and enjoyable experience for naive users interacting with the database system. The third question was, how do application programmers enhance their applications by integrating and leveraging the database system? The answer is, applications programmers enhance their applications by integrating the database system to streamline data storage, retrieval, and management. Utilizing database features like indexing and transaction control, programmers ensure data consistency, boosting application performance. This integration allows for efficient query execution, empowering programmers to create responsive and scalable applications. The data becomes robust foundation, supporting the seamless interaction between the applications and data, ultimately enhancing functionality, user experience, and the overall efficiency of the applications developed by programmers. The last and the fourth question was, what are the characteristics of databases? Answer is, database characteristics include organized data store, structured retrieval through queries, data integrity maintenance, and support for concurrent user access, scalability, security features, and other and awareness to define schemas contribute to efficient data management. These traits collectively empower database management system to handle diverse data needs across various applications. So the agenda of today's lecture is to discuss database management system concepts, and next is database management architecture. Today we embark on fascinating journey into the heart of databases, the concepts and architecture that power our digital world. Get ready for engaging exploration. To understand things of, let us demystify database systems concept. Think of it as a digital filing cabinet, not just storing information, but organizes smartly for quick and easy access. Today we embark on fascinating journey into heart of database, the concept and architecture that power our digital world. Get ready for an engaging exploration. To understand, think of, let's demystify database system concepts. Think of it as a digital filing cabinet, not just storing information, but organizing it smartly for quick and easy access. Let us understand what are the basics of database management. Now, let's dive into the database management architecture. Imagine it is the brains behind the operations overseeing how data is stored, accessed, and managed. If we talk about the database concepts, these are the following some concepts: centralized database system, distributed database system, personal database systems, cloud database systems, commercial database system, and the last is relational database system. We will discuss one by one. What is centralized database system? Single database server. All data is stored on a single central server, and this server is responsible for managing, storing, processing all database transactions. Data accessibility. Users and application access the database through the central server, which acts as the sole point of entry for data retrieval, updates, and other operations. Data inconsistency. Centralization helps maintain data consistency as there is a single copy of the data. Changes are made directly to the central repository, reducing the risk of inconsistencies that might arise from the distributed data storage. Simplified management. Database administration and management tasks are centralized, making it easier to implement security measures, backup procedures, and other maintenance activities. This simplicity can lead to more straightforward system management. Communication overheads. While centralized system offers simplicity, they can also introduce potential bottlenecks. All communication between the users and the database, as well as between different components of the system, must pass through the central server, which can lead to increase the communication overhead as the system scales. Next is distributed database system. Geographical distributions. improved scalability and performance, and data atomicity. So discuss one by one. Graphical distribution. Data is stored in multiple locations or nodes that may be geographically dispersed. These locations are connected through a network, enabling user to access data from different geographical locations. Improved scalability and performance. Distributed Improved scalability and performance. Distribution allows for horizontal scalability, enabling the system to handle larger volume of data and increase user load. Data autonomy. Each node in the distributed system can have its own degree of autonomy, allowing for local control over the specific data. Next is personal database system. Scopes and purpose. Intended for personal use, these databases cater to an individual's specific needs, such as managing contacts, tracking personal finances, maintaining a book collection, or organizing tasks. User-friendly interface. Personal database system often features user-friendly interfaces that makes it easy to non-technical users to input, retrieve, and manage data without the need of extensive data management skills. Flexibility. Personal databases are often highly flexible, allowing users to define and customize data filled by on their unique requirement. Software tools. Personal database system can be implemented using dedicated software tools designated for individual user. These tools may include personal information management software, that is called PIM. The next is cloud database system. Cloud-based infrastructures. The database system is hosted on cloud infrastructure such as Amazon Web Service (AWS), Microsoft Azure, or Google Cloud Platform. This allows this allows for an on-demand provisioning. This allows for on-demand provisioning, scalability, and accessibility over the internet. Scalability. Cloud bases offer horizontal scalability, allowing users to easily scale their database resources up and down based on changing demands. This flexibility is particularly useful for application with variable workloads. Accessibility and geographic distribution. Cloud database enable remote access to data from anywhere with an internet connection. Managed services. Cloud database providers often offer managed services that handle routine tasks such as backup, security, and software updates. Commercial database system. Vendor development and supports. Commercial database systems are developed and maintained by commercial vendors and companies. Feature-rich solution. Commercial databases often offer a comprehensive set of features, including advanced query optimization, transaction management, security mechanism, and scalability options. Enterprise integration. These databases are designed to seamlessly integrate with the other enterprise software solution, facilitating the creation of comprehensive business applications. Documentation and training. Commercial database system come with comprehensive documentation including user manuals, technical guides, and online resources. The next is relational database system. Tabular data structure, structure query language, and ACID properties. Tabular data structure. A relational database system organizes data into tables with row and column. Creating a tabular structure, each table represents an entity and relationships between entities are established through keys, providing a logical and easy to understand model. Structure query language. Relational database system uses SQL as the standard language for defining and manipulating data. A structure query language allows user to perform operations such as query, inserting and updating and deleting data, making it powerful and standardized interface. ACID properties. Relational databases adhere to the ACID properties: atomicity, consistency, isolation, durability, to ensure the reliability and integrity of transactions. These properties guarantee that database transactions are processed reliably, maintaining data consistency and preventing data corruption. Let us discuss the architecture of DBMS. The architecture of DBMS management system is like the blueprint of digital kingdom, defining how data is organized, accessed, and managed. The architecture of DBMS is designed to provide a structured and efficient way to handle large volume of data while offering user-friendly interface. It is the invisible framework that empower organizations to store, retrieve, and manage their data assets effectively. I have discussed the three-tier architectures, two-tier architecture, and three-tier architecture. First, I will start from one-tier architecture. In a one-tier architecture, both the user interface and database management system resides on the same machine, meaning there no separation between the client and the server components. It is a simple and locally executed model commonly found in the standalone application. Two-tier architecture. In two-tier architecture, the application is divided into a client layer for the user interface and the server layer for the database management system. The client sends requests to the server which processes them and interact directly with the database. The last is three-tier architecture. In three-tier architecture, the application is divided into three layers. The presentation layers is called user interface, application layer is called business logic, and the data layer is called database management system. Each layer operates independently, enhancing modularities and scalability in distributed system. In today's lecture, we delve into the key concept of database management system architecture. Now, let us access your knowledge and track your progress with a few thoughtful, provoking questions. Your answer will not only reinforce your understanding but also serve as a valuable gauge of your grasp on the crucial topic discussed today. The today's question to test your knowledge are: first is, what do you mean by DBMS concepts? Explain in brief. What do you understand by database management system architecture? Discuss all type of database management system architecture. As we conclude our journey into database management system concepts and database management system architecture, as we conclude our journey into database systems concepts and database management system architecture, remember, it is not just about storing data, it's about creating a digital symphony where every piece of information plays a part in the grand composition of knowledge. In conclusion of the today's lecture, let us take a quick recap. Our journey today, we have seen the database management system concepts and architecture. Our journey today has given us a glimpse into the varied database management system and the foundational concepts shaping their architectures. I hope you enjoyed this exploration.